Hello folks, we come to the exercise 3.2. We were doing this chapter 3 trigonometric functions. This is a part 1 video. We had in the last video we had just gone through the system of radians and degrees. We already knew degrees, we learned radians, and then their conversions we learned, and then a couple of problems, little bit which had shades from 10th standard portion, and some bit new, and that was what we did basically in the previous exercise. Now in this exercise what we are going to do is we are going to be encountering problems where they will be giving one trigonometric ratio, and we have to find out with the help of that trigonometric ratio other trigonometric ratios. So that is pretty okay. We have done it in the 10th standard also. Only thing in the 10th standard we didn't have all the quadrants. Now we will have the angles scattered in any quadrant, and on the basis of that we are supposed to be finding whatever they have asked. Now before we actually go to this, though we know it, we'll just get ourselves briefed up as to how the trigonometric ratios are distributed. We know that amongst the 4 quadrants, if we could have these as the 4 quadrants, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And in the first quadrant all trigonometric ratios are positive. Here only sine and cosec trigonometric ratios are positive. Here only tan and cot trigonometric ratios are positive, and here it's only cos and sec which are positive. So there are many acronyms that is based on this by which we remember as to which trigonometric ratio is positive in which quadrant. We say all, silver, tea, cups. That's how we remember all, silver, tea, cups. Of course there are others also, tea, cups. Or sometimes people learn cast, C-A-S-T, cast. So to remember that this is how the thing is. Whatever way we have to understand this, and it's on the basis of this that we are going to solve this series of problems. Then we have yet another group of problems coming up later that we will be looking at some other conversions, and we will be doing those problems. So gradually we will learn how we are going to do this. So let's keep this in mind before we go into our conversions. It is given to us that cos x is minus half. That is our first question. Cos x is minus half and x is in the third quadrant. You have to find out the other trigonometric ratios. Cos x is minus half and it is in the third quadrant. This has been given to us. We have to find out. See, it's very clear to us because it is in the third quadrant wherein only tan and cot can be positive. That is why cos is negative. That's how we get to know this. So all trigonometric ratios will be negative, only tan and cot will be positive. Now since we are given cos, right away we will find out sec, because we know that sec is a reciprocal, so therefore it is going to be minus 2. From cos it's always easier to get sine. So we have learnt earlier that sin x is root of 1 minus cos squared x. Last year we have learned the identity sin squared x plus cos squared x equal to 1. So when you kind of do the shifting, this is how you get it. Now can be plus minus, okay, and we will choose the sign depending on our quadrant. Sign has to be negative in this case, so it is going to be minus, we are going to choose minus root of 1 minus cos squared x. Cos x is half, so cos squared x is 1 by 4. Now see, we have chosen minus. Why? Because in the third quadrant only tan and cot can be positive, sign has to be negative, so we have taken the negative value. Now let's solve this. What will this come to? It's like into 4 into 4. So 4 minus 1 by 4, it will come to root of 3 by 4. So on solving, this will come to minus root 3 by 2. Root of 4 is 2. So it will come to minus root 3 by 2. The moment you get sin x, it's very easy to get cosec x. So the moment we get sin x, we will find out cosec x. And cosec x, again we know it has to be negative. So it is minus 2 by root 3. So we are done with cosec x also. So we have found now cos was there, sec we found, sine we have found out, and cosec we have found. Now we can go to tan. Tan is easy. Ratio of sine and cos can give you tan. So and tan has to be positive. Why? Because it's in the third quadrant. So tan we know is sine by cos. So like that we can have sine for us it's minus root 3 by 2, and cos for us it's minus half. The minuses can cancel and the 2's can cancel. See, if you have a ratio and in that ratio you have numerator, like here, there is a ratio here, numerator, denominator, here, numerator, denominator. the numerators can cancel each other and the denominators can cancel each other. So this denominator and this denominator, they can cancel each other. And finally, we are left with the answer of tan x as root 3. So if tan x is root 3, we can get cot x also, and that is positive. Cot x will come to 1 by root 3. So that way we have found out all trigonometric ratios. This is how we go about doing and finding the trigonometric ratios. This was our first question. Now we are taking the second question. And in the second question, they give us sin x is 3 by 5. It is in the second quadrant. Sin x is 3 by 5 and x is in the second quadrant. Sorry. So let's right away, let's move. Moment, say it's in the second quadrant, only sine and cosec will be positive. Everything else will be negative. We have learnt it. So therefore, moment you know sin x, let's find quickly cosec x because it's quite hassle free to find out cosec x. It's 5 by 3. So your work is done. Now we will go from sine. We can see there are a number of ways, number of identities, different ways of doing. But you keep a stereotype way of working because every time you need not change your strategy. It sometimes may lead to confusion. So you keep your strategy that yes, if this is given, this is how I am going to work. This is the identity that I am going to use. And every time you have a problem, you use it that way. The work becomes really, really comfortable for you. So our strategy is from sine we will get cos by using this identity and so on. So that way we keep our strategy. So let's get the cos now. Cos for us by using that identity is 1 minus sine squared x like that. But this cos has to be positive or negative. We are in the second quadrant where only sine and cosec is allowed to be positive. So cos has to carry a negative sign. So we are going to take the negative root. See, when we take a root, we get both positive and negative values. So we choose that value which is suiting us. Now here because negative is going to suit us, we are going to take the negative value. Now, so it is minus root of 1 minus sine squared x means it is 1 minus square of this. So it's going to be 9 by 25 if I am not mistaken. Yes. And this when we have to equalize it and get the thing, we'll equalize it. It is 25 minus 9 by 25 which will come to like either you write it or solve it directly. It will come to 16 by 25. Root of 16 by 25. I have to carry the minus sign every time. And it will therefore come to minus 4 by 5. So the cos x value is coming to minus 4 by 5. Moment you get cos x, it's customary to write sin x because sec x because that's easy. Minus 5 by 4. So you've got sec x also. Now after having got sec x, let's go to tan x. Tan x you can take it as a ratio of sin x and cos x. Let's take it as a ratio of sin x and cos x. Sin x is there with us, it's 3 by 5 and cos x is there with us, it is minus 4 by 5. The 5 can cancel, minus stays back and it is 3 by 4. We are in the second quadrant, so the negative has to be there for the tan and that way we can get cot also by taking the reciprocal. It comes to minus 4 by 3. So this is about finding trigonometric ratio. Very smoothly we can do it by keeping that ratio clear in our mind, by keeping the quadrant clear in our mind. Smoothly we will follow one stereotype procedure by which we don't run around steps. Keep your working comfortable and it becomes very easy. So this is our question number 1 and 2. The remaining question gradually in different parts we will take it up in the next video. Thank you.